Okay, sorry we're a couple of minutes over time. So this is choosing a microcontroller board. It's all about picking the right board for your project, because that's what it comes down to. There is no right choice. There's just lots of wrong choices. We're currently seeing a real explosion in new boards coming onto the market, especially in the last 6 months, and that's pretty much down to Kickstarter and the crowdfunding experience. The whole board market has been opened up by crowdfunding. There's lots of clones, there's lots of niche boards, and there's no real reason to expect this trend is going to slow down. In fact, I think we're going to expect more new boards, not less. Although, to be fair, most of these new boards are going to disappear just as quickly as they arrive. They're probably only going to be one run of them. So it's important not to choose the wrong board that's going to be gone in 20 minutes and you're never going to see it again. And the real problem is actually really hard to differentiate between all of these clones and competitors, not even just for the beginner, but for the fairly advanced people. Sometimes the differences do not matter. It's like, it only matters if that particular board has a difference that makes a real difference to your project. Say you're short on SRAM on your Arduino. Well, there's a board for that. It's called the Goldilocks. It was crowdfunded out of the Australian Possible site, which is like Kickstarter for Australians. So, as little as 6 months ago, the choice was really simple. If you wanted to talk to arbitrary bits of hardware, you bought an Arduino microcontroller board. If you needed the power of an ARM CPU and wanted to run Linux, then you bought a Raspberry Pi, and that was it. Okay, so that's if you could get your hands on the Raspberry Pi, because the demand was so high that there was a 6-month waiting list. That's pretty much sorted out now, but that's fine. So I'm going to talk about some of the alternatives, but if you just want to wander off now, if you're done, if you're bored already, it's still probably the best advice I'm going to give you. Buy an Arduino and buy a Raspberry Pi, because those are the ones with the biggest community behind them, and that's actually going to make a big difference if you're a beginner, because if you have a problem, someone's already solved it. The Google knows. You go to Google, you type your problem in, you type an error message in, Google will tell you the answer. It's awesome. But that only works if you're not the first person to hit the problem, and that's one of the reasons if you're a beginner, I would say go away, buy an Arduino, buy a Raspberry Pi. There's a big community behind those boards. So let's talk about microcontroller boards and the Arduino specifically. So every so often there's a piece of technology that becomes a lever that lets people move the world just a little bit. And the Arduino is one of these levers. It started off as a project to give artists easy access to microcontrollers for interactive exhibits and installations. And I think it's going to end up in all of the science museums as a building block of the current, the new industrial revolution. It allows rapid, cheap prototyping for embedded projects. And it turns what used to be fairly tough hardware projects into software projects. And we all know from the Valley experiences and the various dot-com booms that as soon as it's software, it's easy. You just sit down and you write some code, and it's all easy. So software's easy, hardware's hard. Well, all right, software's not easy, but it's easier than hardware. So the Arduino is based around an 8-bit Atmel 18 mega microcontroller. And like all the dev boards, it breaks out the digital pins, analog pins, pulse width modulation pins, and all the other pins from the microcontroller in an easily accessible way. And in the Arduino's case, in an actually somewhat idiosyncratic footprint, but that's actually now becoming the standard in the industry, which is sort of weird and no one really expected, but there you go. It's a solid development platform, and both for experienced people and beginners. But strangely enough, perhaps, the real power of the Arduino isn't the hardware at all. Instead, it's the Arduino development environment. And while there are many other boards out there that have similar functionality to the Arduino, the Arduino has perhaps succeeded the best in wrapping the messy details of using microcontrollers and doing embedded hardware away from the user. It's simplified the development experience. And as a result, it's spawned many imitators and clones, and it's drawn that huge community I was talking about earlier around it. So there are alternatives, and as I said, I'm not going to go through them all because there's hundreds and hundreds of these things. But while the Arduino is based around the Atmel AT Mega, this is the TI Launchpad based around Texas Instruments MSP430 chip. Now, the MSP430 is pretty similar to the Atmel AT Mega chip that the Arduino uses, but there are some differences, and perhaps the most interesting one for you guys is that this is a really low power chip. It's also got really easy programmable access to the sleep functions. So if you want to produce a project that uses a battery and is somewhere inaccessible for months or years at a time, this board's actually a really good choice. The big problem, at least until recently with the Launchpad, was that the MSP430 programming environment wasn't that simple. It was Eclipse. So if you weren't a professional software developer and you weren't used to using these big development environments, it wasn't so easy to develop for this board. This actually got solved by this thing, which is called Energia, like the Russian rocket. And it has that little rocket as an icon. And it's pretty much exactly like the Arduino IDE. It looks exactly like the Arduino IDE. It's based around the same processing, wiring type background. And it's cross-platform, Windows, OS X, Linux. And just like and you can pretty much take code and it almost looks exactly the same as the Arduino environment. So suddenly the MSP430 has become much more practical for developers if you're looking to use it in a project. So single board computers. So single board computers existed long before the Raspberry Pi. And I mean, I was using a board called the Gum Stick, so called because it was about the size of a stick of gum, fairly extensively about 10 years ago in some projects. However, like the Arduino, the Raspberry Pi has single-handedly rebooted the whole market for single-board computers. And it's brought an explosion of boards onto that market. And you can see a whole bunch of them here at Maker Faire today. It's like from here I can see like 3 or 4 boards that wouldn't be here if it wasn't for the Raspberry Pi treading the ground in front of them. However, unlike the Arduino, the Raspberry Pi was never designed for makers. It wasn't designed for us. It wasn't intended to be used to talk to hardware. It was designed as an educational tool for children in British schools to learn programming. That was what it was. It's a charitable foundation out of Britain that it wanted to put small, very cheap boards into British schools so that the kids could learn how to program. But the price was $35. And at $35, it suddenly made it very, very attractive to us, to makers, to use it to talk to hardware. If you needed Linux, if it was too much for an Arduino, if you wanted to talk to the network. And the Raspberry Pi itself is a large step up from the Arduino in terms of the processing power. It's, as I said, it's a Linux computer. It's got a lot of the same interfaces as your normal laptop or desktop machine, HDMI, Ethernet, USB. I mean, this is basically exactly what it says in the tin. It's a computer on a board. And as a result, programming for the Pi is very similar for programming a normal computer. You log in, you either connect a TV and a keyboard and a mouse, and you log in, or you secure shell into the board, and you use whatever programming languages you normally use, Python or Perl or Ruby or JavaScript or whatever it is you're comfortable with. And as I said, there's a lot more capability here, but there's also a lot of drawbacks. So it has to boot up. It takes a long while to boot up. There's very few pins to actually talk to arbitrary bits of hardware. If you have lots of hardware you need to talk to, the Raspberry Pi isn't actually a great fit. And what you might want to do is actually connect an Arduino to your Raspberry Pi and use the Raspberry Pi to talk to your Arduino and your Arduino to talk to your hardware. So single board computers that were designed for makers. This is the BeagleBone Black. Now, the BeagleBone is another Texas Instruments board, and it was designed from the ground up to talk to hardware, and it's designed to talk to sensors and actuators and other things. And the board was designed for makers rather than educators. Now, the original BeagleBone board looked pretty much like this, except it was white. And it was $89, which was just too much of a stretch for most people when the Pi was $35 and did most of what you wanted. But the new BeagleBone Black is $45. And it's a big step up from the Raspberry Pi. It's got a faster processor, it's got built-in storage as well as the SD card. But like the Pi, it runs Linux, it has Ethernet, it has USB, it's HDMI. It's a computer that runs Linux, but it's designed to talk to arbitrary bits of hardware. So we have the Arduino is $25 to $30. the TI Launchpad, which I talked about. It's really, really cheap. It's 10 bucks. And it's got less capabilities than the Arduino, but if you're okay with that, if your project can handle that, it's a great alternative, especially if you want if you need low power. There's actually usually a TI coupon floating around for 25 bucks off your first purchase from TI. I think Hackaday just picked it up and it got like wiped. Yeah, okay, someone's saying it just got wiped. I think Hackaday picked it up on the 18th and it lasted a day. So there'll be another one. TI does a lot of them. And so you can actually get 2 of these for free most of the time. And then single board computers, there's 2 versions of the Raspberry Pi, one with Ethernet, one without. So it's 35 bucks or 25 bucks respectively. But it only has 8 pins. Like, that's not a lot of pins. Whereas the 45 buck BeagleBone Black has 65 pins. So if you need the extra capability to talk to that hardware, that's a lot of extra pins for just 10 bucks. So, well, that isn't quite the end of the story. Announced earlier in the year at the Bay Area Maker Faire is the Arduino Un. And you can actually buy it for the first time here at Maker Faire in the US. It's over in the Maker Shed over that way. Until now, it's only been available in euros from the Arduino store. So this is the first in a series of embedded Linux boards from Arduino. It comes with integrated Wi-Fi. It's fundamentally an Arduino Leonardo on one side and a MIPS Linux variant on the other side. And there's a special bridge library to talk to the two. So you can do your networking on the Linux side, and you can do your hardware on the Arduino side. So it's pretty cool. It's 69 bucks, but then you do get sort of 2 boards in one, so it's not an unreasonable price. There's another interesting board which I will mention. It's actually still in its Kickstarter. Well, it's not Kickstarter. It's still in its crowdfunding campaign. It's one of the first boards to come out of Dragon Innovation. I think they've got a stall over there somewhere. This is the Tezzel microcontroller board, and it's built for web developers, not hardware hackers. This actually runs JavaScript interpreter based around the Lua runtime. It's compatible with Node.js. So if you're a Node developer, if you're a JavaScript developer, you can actually run your Node directly on the metal. You can run it directly on the microcontroller. And it comes with Wi-Fi built in off the shelf. So this is actually a really cool board that's designed from the ground up to be part of the Internet of Things. This is designed for web developers to get into hardware. It's designed for makers to get into network-enabled devices. So it's a really cool board. There's also another board that's on Kickstarter called the Esperino, which is another JavaScript board that's nearing the end of its crowdfunding session. Both of them they're fully funded, so go look at Dragon Innovation for this one and Kickstarter for the Esperino. I think I never can pronounce it right. And one of the things that's interesting me about this is whether it's actually going to bring the JavaScript developers into our camp, into the Maker camp, and bring a whole new community of makers in. So, summary then, buy an Arduino or a Raspberry Pi if you really don't know what to buy. The other boards are really specialty boards that if you have a specific need, a specific niche to fill in your project, that you need something, if you need low power, MSP 430 is a good idea. If you need lots and lots of pins and you need Linux and high power networking, BeagleBone Black is your absolutely thing to do. If you know JavaScript, wait for this board to come out. I've got a pre-production model on my desk at home. It's actually quite neat. And then there's a whole bunch of other boards that are kicking around that if you need something niche, there is a board for you. But if you don't need the niche, buy the board with the biggest community. Any questions? Nope. Well, thank you very much.